Hello dear students, welcome to the Power Electronic Gate classes, which is the initiative of TEQIP Faculties. Let's crack the gate. So let's begin with the today's class, which is Power Electronics AC/DC control rectifiers. So till now we have studied about what are the AC/DC uncontrolled rectifiers. So in uncontrolled rectifiers, single phase half wave, we have studied about how these uncontrolled rectifiers work with various types of loads. So now in today's topic, we are going to study about the phase controlled rectifiers. Why they are called phase controlled rectifiers? First of all, they use control devices such as SCR. All right. So we have to use the properties of SCR for understanding the working of these rectifiers. Second thing, these are called phase controlled rectifiers. Why it is so? Because just like in this is sine wave, if you have got this sine wave here, all right, in uncontrolled rectifiers you cannot control its phase, this one, these things you cannot control, but with controlled rectifiers, with phase controlled rectifiers, you can even control the phase of any input sine wave. Means if this is your input sine wave, you can get output in various means different phases like this. So since you are able to control its phase here, that's why they are called known as phase controlled rectifiers. So let's begin. Rest for is understanding and analysis of circuit includes those steps which we have studied earlier in my previous lectures for AC/DC uncontrolled rectifiers. Okay, so let's begin with the single phase half wave AC/DC uncontrolled rectifiers. So if we talk about the half wave uncontrolled rectifiers, the basic circuit for the uncontrolled rectifiers looks like this, where this may be any type of load, whether it may be a R load, L load or any other type of load, where this is the voltage reference. Now this is we are using thyristor instead of diode, so we have to apply the properties of thyristor. This is thyristor voltage, thyristor current and source voltage, source current. Rest everything will remain the same. So here the one difference between the thyristor and diode is that in diode, diode can instantly turn on or on off as soon as it is forward biased or reverse biased. But with thyristor, this is not the case. It will not turn on unless gate pulse is provided. All right. Otherwise, it will remain in the forward blocking mode. You have studied about this in the power electronics section of module 1, where it is mentioned there that in a thyristor, if you plot this VAK and IAK characteristics, you have seen that when the gate pulse was not provided up to certain voltage, the thyristor tries to block, and after that immediately when the J2 junction breaks, thyristor comes into conduction mode. So this is basically forward blocking mode and this is basically forward conduction mode. That's why we need a gate pulse to trigger the SCR. All right. Now let's begin with the each and every load. Let's say first of all, let's begin with the resistive load. So when we begin with the resistive load, the circuit is simple, just like a single phase half wave circuit we have studied earlier, and the same circuit concept which we have studied earlier we have to apply again here. So this is the output voltage for resistive load and this is the load current, this is the thyristor voltage, thyristor current, and this is my source voltage and source current. So now if we start drawing its waveforms, so this is the source voltage here. It's very simple. Only thing you have to see The only difference between the uncontrolled and controlled ones is that in controlled rectifiers the circuit will be connected if and only if the gate pulse is given to the device, means to SCR. Otherwise the circuit will remain in the blocking mode only, it will not connect. Alright, because same thyristor is a semi controlled rectifier. Okay, so let's mark the instants 0, pi, 2 pi, 3 pi, 4 pi, 5 pi and so on. So these are the pi instants marked with black dotted lines. These are there. Now if with thyristors we have to mark the firing angle also, means at what instant we are firing, that firing instant has to be marked also. Alright, so let's say this is my output voltage and this is my load current. Here we have to plot. So now let's mark the firing triggering angle. This firing angle also known as triggering angle. So we know that we have to give the firing angle to the device only if the device is in forward. So here the triggering angle is marked as like this. So triggering angle has to be marked only in those cycles in which the device is forward biased. We do not provide gate pulse to device in a reverse biased condition, especially if this is SCR. Alright, so we know that only in the positive cycles of the input sine wave, the SCR will be forward biased. So in negative cycles there is no point to provide triggering angle. So these are the triggering angles I am marking: alpha, alpha plus 2 pi, then alpha plus 4 pi and so on. So here we can see, if you mark like this, that these are the triggering instants. Alright, so let's start the working. How the thyristor means this circuit will work. Okay, so if you want to see the working of the thyristor, just very simple thing, we can see that again we have to analyze the same procedure, we have to analyze from instant to instant. So first instant, if we talk about the first instant, so in the output, if I want to check what will be the output, so again we have to go with the instant wise. So first instant is again we have from 0 to alpha. So if you 0 to alpha, if you talk about 0 to alpha, what is happening here, the means if you see from 0 to alpha, although the SCR is forward biased, SCR is forward biased, but still it is off. Why it is off? Because it is in forward blocking mode. So because of that, in forward blocking mode, what is happening here, this thyristor will still remain an open circuit switch. So what will happen till the point, till the instant we do not provide gate pulse to the thyristor, it will not turn on. So if you try to draw the modified circuit, then modified circuit will look like this. Okay, means still the circuit is disconnected, means load is disconnected from the source. So hence the output voltage will be 0. There is no current flowing, no voltage output at the output. Alright, and if you talk about the thyristor voltage at this time, okay, so let's draw another axis also, that is thyristor voltage. If we draw thyristor voltage here at this time, what you will see that the thyristor, since thyristor is not reverse biased here, so if you see here, so output voltage, so now here you see that when the thyristor voltage you want to draw, here you see thyristor is forward biased, not reverse biased. So when you draw the thyristor voltage, so the forward voltage whatever is appearing across thyristor, that will appear here. You can write the circuit equations also, just write, we have studied that we have to write circuit equations also in the whatever steps we have studied. That is, if you write Vs minus Vt minus V naught equal to 0. So, here you can see that V naught is 0 because there is no load voltage. So, you can see that Vt is equals to Vs, and what is Vs between 0 to alpha? Between 0 to alpha, Vs is Vm sin omega t, means positive Vm, alright, positive. So, we can see that till 0 to alpha, whatever sign voltage is there, so that will appear across the thyristor like this. But so this is alright. Now, if you talk about the next instant, that is from alpha to omega t to pi. If you talk about this instant, alpha to pi, what is happening in alpha to pi? Here you can see that thyristor SCR, we can write thyristor as T, okay, instead of writing SCR. T is forward biased and on also. Why? Because at alpha instant you are providing the gate triggering pulse to the thyristor. Again, we are assuming that thyristor is taking no time to turn on, alright. We are assuming that thyristors are ideal. So, they are there as soon as they get the gate pulse, they will not take any time lag, alright, they will immediately turn on, alright. So, here as soon as at alpha instant you provide the gate pulse, immediately the thyristor is on and it will act like a short circuit switch. So, it will act like a short circuit switch. If you want to make a modified circuit, you will see the modified circuit will be like this, okay. So, this is the modified circuit, plus minus V naught, I naught is there and source voltage is there, source current is there. So, it will immediately current will start flowing, and you can see that load voltage is in parallel with the source voltage. So, whatever the source voltage will be there at alpha instant, that voltage will immediately appear across the load. So, you can see at alpha instant the source voltage has already reached up to this point, alright. So, from this point onwards the load voltage will follow the source voltage till pi, because till pi the thyristor will remain forward biased, and since it is pure resistive load, hence the load current will also follow the same waveform as that of load voltage. It may scale up or scale down based on resistance value, that will, so its value will be Vm by R and its value will be same Vm, because here it is also Vm, okay. Now, what is thyristor voltage at this time? Since thyristor is on, it is a short circuit switch, so that the thyristor voltage will be 0. Now, let us go to next instant, that is third instant, that is from pi to 2 pi. So, if you talk about pi to 2 pi, again we can see very clearly that the thyristor is means a reverse voltage is appearing across the thyristor. So, when a reverse voltage is appearing across the thyristor, thyristor is reverse biased, alright. SCR is reverse biased and thus it will be in totally off condition. Off condition means the circuit will be like this, alright. If you draw the modified circuit, it will be like this. Again the load and source are disconnected, that is why the output voltage will be 0 and thus the load current will be 0, and whatever the output voltage, what is the voltage across thyristor, just write the KVL equations. We can write Vs minus Vt minus V naught equal to 0, implies that since Vt equals to Vs minus V naught, alright. Already V naught is 0, hence we can see that thyristor voltage will be equal to source voltage. But in this case, for 0 to pi to 2 pi case, the Vs is negative, alright. We can see its Vs is negative, minus Vm sin omega t. Hence, this minus Vm sin omega t full voltage will appear across the SCR like this, okay. So, what is the PIV rating of the SCR in this case is Vm, means you need a thyristor of PIV rating of Vm, okay. Again analyze when after 2 pi, again analyze from 2 pi to pi plus 2, 2 pi to alpha plus 2 pi. Again you can say 2 pi to alpha plus 2 pi. This is the same repeated instant at this. This is, if it means there are various methods to see a waveform or analyze a waveform. If you see a waveform or analyze a waveform in terms of time period, you can see if some waveform is repeating after every t period, you can see that the same analysis will also be repeating. This is one of the trick to learn power electronics and to quickly solve it. All right. So, here you can see, yes, you have to see that it should not be a starting cycle. Okay. Now, if you again see 2 pi to 2 pi alpha plus 2 pi, again it is equal to 0 to alpha, same instant. So, again the SCR is forward biased, but since no gate pulse is provided to the SCR, so the SCR will remain in forward blocking mode, hence the circuit will be like this. Hence again the output will be 0, load current will be 0, and thyristor will have a forward blocking voltage of positive sine wave, positive Vm sin omega t, like this. Okay. And as alpha plus 2 pi, as soon as the gate pulse is provided, the thyristor will trigger, it will be short circuited, and it will be same as alpha 2 pi instant, and the output load and source are connected, and out thyristor voltage will be like this. Okay. And at this condition, the load current will also follow the load voltage like that. Okay. And the thyristor voltage will be 0 because thyristor is turned on. And again from 3 pi to 4 pi, thyristor is fully reverse biased, and hence the thyristor is off. So, there will be no output voltage, there will be no output current, but thyristor will have to block the full reversed sine wave like this. Okay. So, in this way we can continue to draw like that. Okay. So, this is the what is the value, means how we draw for phase controlled circuits. So, here if you want to find out the average output voltage, just see the time period is 2 pi. I am considering time period from alpha to alpha plus 2 pi. Why? That reason has already stated, because it will allow me to break the circuit only 2 times. We can take from 0 to 2 pi also. So, here if you calculate the average output voltage, that will come out to be Vm upon 2 pi 1 plus cos alpha. Alright. I have already told you how to check whether it is correct or not. Just put, if it is a pure diode case, if it is pure diode case, then obviously the alpha must be 0. So, if you put alpha equal to 0, it will be 2 or 2, 1 plus 1, 2 to cancel 1 Vm upon pi, means this average voltage is correct. So, now you have to calculate what is the RMS value in this case, and please post this in the comment sections. So, now let us move on to the next load, that is yes, that is with RL type load. Okay. So, if you have learned this in the diodes, with the diode circuits properly, then here learning is very fun and it is not going to be very difficult. Only you have to consider the firing angle. So, Vs, Is, this is Vt, It, and this is RL, I naught, and plus minus V naught. Okay, total voltage here. So, again let us draw its waveforms here. So, this is the source voltage here. Zero, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. So, these are the black dotted lines show the pi instant marks. and let's also mark the firing angles. So, these are marked, these alphas or red lines are basically showing the triggering angles, again simple thing. So, I am showing it only for the positive cycles. Why? Because only one thyristor is there and that thyristor will be forward biased only the positive cycles. There is no in the to a reverse biased thyristor, because it will cause thyristor to burn out. Okay. Here is this output voltage, output current, then we have got here in this case you can see when the freewheeling diode is not there, you can easily see that source current, load current, thyristor current, all three are same, and then we have to draw the thyristor voltage Vt. Okay. So, now let us start with the circuit again. So, here you can see from 0 to alpha what is again happening, thyristor is reverse biased. When the thyristor is reverse biased, so no current will be flowing and the circuit will be disconnected, load is disconnected from the source as we have seen earlier. So, all right. So, then the output voltage will be 0, the output current will be 0, but the thyristor will have some forward blocking voltage, that is here. You please note down, when the thyristor is in forward condition, it is not in, you do not have to draw reverse voltage. Why it is in the forward condition? That is why. Alright. So, when the thyristor is in a forward blocking mode, means that we have to draw the positive voltage across the thyristor. Alright. So, now next move, so from 0 to alpha, these we have already drawn. Next move, let us move to now next instant, that is from alpha to pi. So, when we talk about alpha to pi, now the thyristor is on, because means SCR is sorry SCR is on. So, circuit we already know it will be behave like this. So, here it is the output voltage, this is load current, source voltage and source current. So, now here you can see that initially as soon as the thyristor is connected, now the current will not rise immediately. Why? Because of inductor. Inductor does not allow sudden change of current. So, initially the inductor will start charging with these polarities, plus upside minus downside. So, the load current will charge. We have studied this already. Alright, that immediate the inductor will charge with so there the load current will be exponential plus sinusoidal behavior, that we have already discussed in the half wave rectifiers, uncontrolled half wave rectifiers. Alright, so the inductor will charge like this, go to some peak value, and after that it will start discharging, and generally the inductor discharges, inductive load discharges after pi instant. Okay. So, let us say inductor is discharging at some point beta like this. So, it is marked with green lines, alpha marking are basically triggering angles, beta markings are green lines are extinction angle, beta is known as extinction angle. So, you can see here, since the load current is flowing, so if you try to mark the output voltage, what is the output voltage here? Since from alpha to pi, alpha plus 2 pi, alpha plus 4 pi. From alpha to pi there is no problem, because the load is in parallel with the source, and source is both are in parallel. So, that is why the output voltage is like this. Okay. Now, what about at pi instant? As we have discussed earlier also, that at pi instant what is happening, that the inductor still has got some energy with it. Alright. So, because of it the inductor LdI by dt will be very high, and till the time the inductor does not discharge itself fully or does not get any alternate path to discharge it, what will it do, that its polarity will become like this, it will reverse its polarity like this, and it will create such a high LDI by dt. Because of that, this thyristor has to remain turned on forcefully. All right. So when the thyristor will have to remain turned on forcefully, so what will happen? When the thyristor will remain turned on forcefully, what will happen? That now the cycle, see, from pi to beta, the cycle has reversed, but still the load is following the source. So now if the source has become negative, then obviously that negative voltage will appear across the load. So means that the negative voltage will appear across the load like this till the beta point. And therefore this means that since the thyristor is remaining on from alpha to beta, it means what? That till alpha, from alpha till beta, thyristor is on. So means from alpha to beta, the thyristor voltage will be 0. Voltage across thyristor is 0. So now at beta, what is happening at beta? At beta, if you see what is happening, that now the inductor current is fully discharged and resistance has no power to keep the thyristor turned on. So because of supply, the thyristor will become reverse biased and immediately turned off. So when the thyristor becomes turned off, again the load and source are disconnected and output voltage will be 0 from 0 to pi, from beta to pi, and load current will also be 0 from beta to pi. And thyristor voltage, what is the thyristor voltage at this point? So you see at beta, the reverse voltage across thyristor has already reached up to this point. So this voltage will trace across the thyristor. We can write the circuit equations. It's nice to write it. Vs minus Vt minus V naught equal to 0. This is the generalized equation. If you see that this circuit equation is a generalized one. The only thing is that Vs and V naught are keep changing themselves in every half cycle. All right. So that you have to see. So in this, from after beta point, the Vs is negative and V naught is 0. So that's why thyristor will be following whatever the source voltage has reached. So it will be like this. Again you see that the PIV rating here, it is Vm. So what PIV rating of thyristor is required here? Again it is Vm required. All right. Again when you see at 2 pi instant, so what is happening at 2 pi to alpha? Again the thyristor forward biased, but because of absence of gate pulse, it will remain in only forward blocking mode. It means the load and source will remain disconnected, the load current will be disconnected, and thyristor will have some positive voltage across it, which is a forward blocking mode. And at alpha plus 2 pi, again if you give the triggering pulse to the thyristor alpha at alpha plus 2 pi, again the thyristor will become short circuit and the circuit will be like this. And again the load current will, due to inductor, will rise from 0 and with exponential and sinusoidal behavior like that, and after that it will discharge at some point beta plus 2 pi. So you can see that it is discharged at beta plus 2 pi instant, and from this here you can see, if you draw the output voltage from alpha plus 2 pi to beta plus 2 pi. So from alpha plus 2 pi to 3 pi it is positive voltage, and from 3 pi to beta plus 2 pi it's the negative voltage. Okay. And from alpha plus 2 pi to beta plus 2 pi, the thyristor voltage will be 0, and again at beta plus 2 pi the thyristor will regain its its reverse blocking mode. Okay. So in this way it will go on, keep on continuing its cycle like that. Okay. So again we can see the average output voltage. To find out the average output voltage, the time period is, again you can see here, is 2 pi. I am taking the time period from alpha plus 2 pi, alpha to alpha plus 2 pi. This is time period 2 pi. So if you want to find out the average output voltage here, very simple thing, not a very difficult task. V naught average is equals to, I am not solving this V naught average means as a whole, I am keeping it as homework for you. You have to solve it. I am just writing the end result, and that is basically Vm upon 2 pi cos alpha minus cos beta. You can check it. If you take a pure diode case with resistance load, so beta will become pi and alpha will become 0. So, if you place beta equal to pi, it will be minus 1. So, cos pi minus 1, so minus 1 is plus, and alpha equal to 0, it is plus 1. So, 1 plus 1, 2, 2 will cancel out, again it will be 1.2 pi, means this value is correct. So, now you have to calculate the V naught RMS value for this particular load. And one more thing, one more means homework for you, that you have to try this circuit if you place a freewheeling diode across it. Okay. If you place a freewheeling diode across it in this circuit for this kind of load, what will be the output? Obviously, you know that because of freewheeling diode, what will happen? The inductor does not have to keep this thyristor turned on forcefully. All right, it will keep now freewheeling diode turned on. So, obviously, in that case, the load current will be same like that. So, in that case, you have to draw, means question is basically draw and analyze same circuit with freewheeling diode. Okay, and in the waveforms, add more waveforms of, apart from these waveforms, you have to add the waveforms of basically source current and freewheeling diode current. So, just simple trick, because at pi, when the freewheeling diode will come into action, so what will happen at pi, the freewheeling diode will come into action, this negative voltage will be not there, will not be there. We have learned this advantages of freewheeling diode in the previous lecture, previous topic, effect of freewheeling diode. For you can see that lecture for reference purpose. So, we are stopping here till now. In my next lecture, I will start with the single phase half wave rectifiers. No, we have already covered half wave rectifiers. So, now in the next lecture, we will start with the full wave rectifiers. Till then, so how you like the lecture, please write in the comment section, and for whatever doubts you have got, please also mention that in the comment section, or you can also mention them in our Telegram group. Till then, thank you very much.